So as an operator.
So that's more on the serverless side, what you just said about developers wanting to deploy and not having to worry about configuring any of their stuff. But I'm going to drop a link here in your document around application development platform. Here, Daniel. Platform. And this is very closely, I'm going to put a note here, closely related to the job to be done for operators who want to set up a platform for their dev teams. So I don't know if we talked about this or not last time, but at every software shop that I've worked at and at most customers that I've encountered, there is a team, and sometimes it's large and sometimes it's just a small team, or sometimes it's a number of teams that is tasked with supporting developers with all of their needs. So if they need an environment to deploy to, if they need a VM, if they need a Kubernetes cluster. So they generally go to the platform team and say, hey, we are building a new application. It's going to be X, Y, and Z. Like its topology is going to look like this. And can you build something for us so we can go ahead and deploy? So that team is in charge of building what we call the application development platform.
Mm-hmm.
And that's what allows basically developers to not have to think about any of this. It's just somebody else set it up for me and I just deploy to it and it just works. So it's a very big job for an operator. So as an operator, I want to set up an application development platform for software teams in my company.
The Siemens guys in Commit were these people, I think. But
yeah, so it's funny, but Siemens is so large that the guys that were at Commit serves kind of one vertical in Siemens, right? But in Siemens is one of those companies that you see like a plethora of use cases and they do different things across different verticals. But yes, that's kind of one of the teams. So another team that was doing kind of the same is MRI, and they're doing this for NASA. So they're setting up this app dev platform is what they call it. And it's all Kubernetes based and it's all inspired with auto DevOps and templates and stuff like that. So that's kind of the future that we picture. If you click on that link that I dropped there on point number 2, what we're talking about, the application development platform it contains, compute space. So compute space is like a VM or a Kubernetes cluster. Sometimes it may or may not contain a way to automatically build, test, and deploy your app. So because app topologies are very different and their structure is very different, developers a lot of times are building the CI processes to build and deploy their apps. But with something like Auto DevOps, if we could provide that out of the box for a large number of common applications, that's kind of our goal. And then the other things that platform should give developers is security, of course, and observability. So observability is, the ability to see not only how their app performs, but also being able to trace events that happen in their apps, and basically having what in GitLab you've probably heard this term being used in the monitor stage called the 3 pillars of observability. Have you heard that?
I haven't heard it yet. No.
So yeah, you probably will hear that. So that the 3 pillars when we talk about this is logs, like having access to logs is one of. So the application development platform should have that. And if you think about the stuff that we're doing, so we're allowing you to deploy Elastic to your cluster. So if you have something like Elasticsearch and Kibana, that is one of the pillars. So you have all the logs being kind of centralized in one place. That's very, very, very powerful. The second pillar is metrics. So we have metrics via Prometheus. It's kind of giving you all the feedback that's coming from all the data that your cluster is generating and when your app is running. And the third pillar is traces. So we do tracing with Jaeger. And maybe I should write this down on the doc so we don't forget. So I'm going to put here Daniel, 3 pillars of observability. Those are logs. So this is Elasticsearch K-stack. Say domestic search. Then we have Prometheus. And that will cover
metrics. So the logs are also on the monitor side for us.
The logs. That's an interesting question. But yes, that work is being done currently by them. So they just pushed an MR to have Elastic as a GitLab managed app. So you're going to be able to deploy it to your cluster. So you can imagine an operator just has to click on Prometheus, click on Elastic, and then set up Jaeger. That's not as straightforward today. And then they have like the 3 pillars out of the box with GitLab, which is absolutely great. So we just have to make sure that the experience is cohesive across our categories. Because right now, like we had an idea on serverless to do the same thing with Elasticsearch and Kibana, where it aggregates all of your logs, and we could give you a set of pre-built queries where you could troubleshoot problems with your services and stuff like that. There was kind of overlap there. So we have to make sure that there's no overlap and it's like very harmonic throughout all the services.
Yeah, because there is definitely one logs, maybe it's this one issue in system, in the serverless thing.
Yeah.
I think it's Knative logs though. So, and then there is
It is Knative logs. Yeah. So Elastic can aggregate logs from any system.
Right. So, and I also started the research issue to understand how, because I thought it's on our side logs, and then the metrics are on the monitoring side. So,
yeah, and they are. But when we're talking about an application development platform, that is like auto DevOps. It cuts across multiple stages. So if we think about auto DevOps, it cuts across secure, release, verify, right? But it lives in this stage.
Okay.
But you're right. Yeah.
Okay, because it was
a good observation.
That's a different discussion, but I wanted to get your insight on it because my questions are: how are users? What kind of logs are users tracking? How often are they tracking them, and why? Like from errors, or is it a daily routine? Then, do they skim the logs? Do they read in detail? What kind of information are they looking to extract? And then logs from different places. Do they expect to find them in one place or in the respective deployments or projects? Not projects.
Yeah.
So I would really like, before we do the logs work, to do this research. The research team doesn't have capability, but I'm going to start with market research, see what common practices there are. And anyway, sorry for sidetracking, but I find it...
No, it's important and it's very related.
And I find it as a good first project, like smaller than the vision I could take on.
It's a good one to take on. But yeah, so just briefly, when we're talking about Kubernetes, you can aggregate logs running from any app in your cluster. And generally, when you want to see the logs is because of one of two reasons. One is because you want to see performance. And then I guess that's, more metrics than logs. And the other one is when you have a problem. So when you have a problem, that's, I would say, the number one reason of what you're researching logs is to find out, well, not generally a problem, but to find out the genesis of an event. So you're saying, I saw this behavior and I wonder why it happened. I'm going to go look in the logs.
And at the moment they go to either Google or AWS to their cluster?
Yeah, that's a good question. It depends. So that assumes that they are hosting their clusters in GCP or in AWS.
Yeah.
And that's the case for some people, but for a lot of other people, they're self-hosting their own clusters, their own data center, or they're having a service like Microsoft Azure, DigitalOcean, it could be a number of things. So
Right.
I think that we have to focus less on the provider and more on how's the common way that we provide the ability to do this.
Yeah.
But yeah, so today, for example, yesterday, I was setting up a Kubernetes cluster, and I was having a problem with the runner, and I didn't have Elastic in that cluster. So what I did is I went to the nodes of the cluster, and then I went to the runner logs and looked what was going on, and I did that specifically in the GCP dashboard. Because I didn't have any other logging mechanism set up on that cluster. I was just using the defaults provided by the cloud provider.
Yeah.
Which are pretty good. They use Stackdriver, which is pretty great.
Okay, maybe we should have a separate interview. So I will.
Okay, yeah, and we should definitely have somebody from monitoring as part of that conversation. Yeah. Okay.
Sorry, I want to learn so much. So
yeah, these topics are so broad and they cover so much that
yeah. Okay, so as an operator, I want to be able to set up a development platform for development teams in an app.
Yeah, I would insert the word application development platform. That's an important distinction.
Okay. Is there any networking involved if you're not using, but we are focusing on DevOps, so I guess everything is either containerized or virtual machined.
Yeah, so when you say when we're talking about the network layer, are you thinking like traffic routing? How is that accomplished?
Yeah, like subnet creation, like firewalls, things like that. So things they used to do, at least in the past.
Yeah, so that's a good question, and how we generally cover that is in the context of Kubernetes only. So when you're talking about, so networking is very different. When you're talking about different cloud providers, they call their network layer elements different things. So we try to kind of abstract from all of that. And what we do is that we talk about networking at a very generic Kubernetes way, right? So we'll never use like words like CloudFormation or whatever, VPC, this or no. So when we're talking about networking in this stage, for example, we're always talking about Ingress. So, in Kubernetes, you can create a cluster that is made up of nodes, right? So you have nodes, and when you launch a deployment onto your cluster, you have to allow the egress, so the exit and the ingress or the entering of traffic. And how we do that, and how Kubernetes calls that in a very unoriginal way, is an ingress. And ingress, that specific word means to enter, right? And I don't know why they chose that word, but that's what it's called. So now we have all these ingress providers, like Nginx is one, Istio is another. So there are like all these different choices that you have. But that is kind of the element that is handling all of the networking in the Kubernetes world. So by default, Kubernetes gives you isolation between like your pods and the outside world. So kind of things are closed off. And if you want to provide that bridge for things to communicate, you do it through an ingress.
Right.
And then when you have a controller, or what's called an Ingress controller, or a lot of people also call it a load balancer, you can configure all the network policies around who's allowed in, who's allowed out, who in this node, maybe you cannot talk to your neighbor node, or like all those policies are managed through annotations, generally in the Ingress controller.
Right.
So that's how the networking is done in Kubernetes, mostly.
So the layer of optimizing the server communication so that it's kind of in the same fabric, I think, it doesn't exist anymore. Did I drop?
You did for a second, but I think I caught what you said was the concept of a server talking to another server that's in the same layer.
Yeah, optimizing kind of which servers are going to use for running your application for efficiency purposes on top of networking. So these things do not exist in the cloud world, I guess.
Well, I would say in the cloud native world. So when we're talking about Kubernetes, Kubernetes takes care of a lot of things automatically for you that you don't have to worry about. So when we think or we talk about optimization, you can use a lot of the Kubernetes native primary elements like scaling, like there's this concept called horizontal pod auto scaling.
Yeah.
That you can just set up like the boundaries and it'll scale up and down for you. And all of those things are like automatic optimization. So you don't have to worry a lot about that. And then when we're talking about, like, we don't talk about servers anymore. So we talk about services. So you have a deployment to your Kubernetes cluster. And that deployment can take many forms. But let's say a service is a very common one. So what you're optimized now is the communication between services. And that a lot of that is automatically optimized by all the features that are built into Kubernetes. So we would have to talk about specific areas of optimization. One of them could be network policies. Like, yeah, a lot of that you have to do manually. But if we're talking about purely about performance, yeah, a lot of that is kind of taken care of, and you don't, like I don't think it's a big concern for operators of Kubernetes. They just set it up in a way that makes sense for their service and their scale, and they just run with it and kind of fine tune it along the way.
Okay. So, gotcha. I'm trying to understand the Kubernetes, the operator kind of persona concerns more. Okay, so it's kind of asking your devs, what requirements do you have, and then setting up the environment, how many clusters or the boundaries of pods, so things like specific to your
That's
Kubernetes.
right.
Okay, cool. It seems like a day-to-day job, no big struggles. Am I correct in thinking that?
I think so. I think there's a lot of fine tuning along the way, but yeah, I think that Kubernetes has simplified quite a bit that for operators. So yeah, I think that you are correct in thinking that.
Okay, we're on time. I am free for another half an hour. Well, but depends on your schedule. Do we have a lot more to cover?
Well, so we haven't moved on from Kubernetes configuration. I think that we talked about chaos engineering. There's an aspect of the developer wanting to test how resilient their application is. But there's like the other side of the coin, or sorry, let me rephrase that. There's an aspect of the developer wanting to test how their application responds to to unplanned events and how resilient it is. That's on the developer side.
Yes. So I have two use cases. I want to ensure that my application is resilient and can handle any unplanned outages. And I want to configure the boundaries / how much chaos damage I want to inflict to my environment.
Yeah, so that second one applies for both a developer and an operator. And there's another one, very important aspect of chaos engineering having to do with the operator. And that is, just as the developer wants to test how their app behaves when there are these outages, the operator wants to test how their infrastructure behaves when there are outages. So for example, there's like this very common concept called a failover in the SRE world. So that is when my infrastructure provider goes down, I have a plan B to cut over to this other provider so that my services can keep on running. So that's just one scenario. But you could imagine that if we're hosting all of our stuff on AWS and AWS goes down, which happens rarely, but it has happened. Then what do we do? So as once your infrastructure have proper measures in place. That's an important one that we do in chaos engineering. I don't think that we talked about cluster cost optimization.
Let me check. Once I finish and have failure configuration in place. Is that
fail over?
Fail over. Yes. Fail. Cost optimization for an operator we haven't really discussed. We've discussed I want to see the number of resources, but not linked to cost. And then customize, update, upgrade, uninstall, deploy. No, we haven't.
Okay.
No.
Okay. Let me just finish this note. Okay, so let's talk about cluster cost optimization. So when you are running infrastructure, there are always costs associated with your infrastructure, and this is a category that kind of cuts across configure and monitor, because you have to have a way to surface the data so you can monitor it. So I think that because we have knowledge of all the infrastructure that's going on in a Kubernetes way, we have to surface that so we can talk about costs, and we can talk about savings, and we can talk about all that stuff. So as I was saying, so all these costs are like a significant part of running a software shop. So you can imagine that for us, running GitLab.com, like the bulk of the cost is infrastructure, right? Like, yeah, there are a lot of man hours and support and all this stuff, but the bulk of the cost is on, like, you know, VMs and networking and hosting costs and all that stuff. So we have teams whose sole purpose is managing the cost and reducing the cost a lot of the times, right? And there are people whose full-time job is just doing that. So of course, cloud providers have kind of a very built-in way to do that, but it's not a generic way. Every cloud provider gives you a different flavor of how to manage costs. But since we are kind of moving into this cloud native world where the resources are kind of now more homogeneous, and we're talking about more Kubernetes clusters and ingresses and load balancers, those are kind of known elements that we could probably monitor, and we can probably tell you if something is being underutilized or overutilized. Driving all of those things and allowing users to save cost on their infrastructure is a big part of the value prop that we have for this category. It's like, you know, since we have knowledge of all your infrastructure, we are positioned very well to like provide a very good solution here with like a very cool, you can imagine like a dashboard that tells you, hey, this cluster is underutilized by 70%. So you could say like cost, or yeah, I don't know how we're going to express that yet, but we could say you could reduce the size of your cluster and save on costs. And then we'll let you know when you're using over 80% of your capacity. And at that point, it's probably a good idea to kind of resize it. Yeah.
Can this be automatic? So could it be part of our offering as an automated service? I mean, eventually, not in the beginning, but
I think so. I don't think that that's impossible, but it's tricky, right? Because that would mean that we have kind of the keys to the kingdom. So right now, we don't hold on to your, let's say, your GCP credentials.
Yeah, we've discussed about that. But isn't serverless kind of something like that? But it auto scales and you get exactly what you need when you need it?
So hosted, like SaaS-based serverless is very much like that. But in the Kubernetes world, there's no such thing as like zero. Like you have to start with a cluster, right?
You have to have a cluster.
And when you create your cluster, you have to size it. You have to see how many CPUs each one of my nodes is going to have, how many nodes I'm going to have, what kind of memory I want, and all that. And the reality is that Kubernetes runs on VMs, right? So when you create a Kubernetes cluster on any provider, what it's doing is it's spinning up VMs. It's installing Kubernetes on these VMs, but it's kind of abstracting that VM layer from you. So you don't really worry about VMs any longer. Now you worry about the cost of your cluster. But in the back, it's running on regular hardware. But yes, so what I was going to say that is that we don't store those credentials. So we would have a way, if we wanted to have a way to automatically do that for you, we would have to have a mechanism to log into your cloud provider and make changes on your infrastructure.
Yeah.
And the reality is that like 10 out of 10 operators that I've talked to want to do that manually. Like they want to have a recommendation, but they don't want to have any tool changing stuff for them without their knowledge.
Yeah, that's good insight.
Yeah.
Yeah. Alternatively, they would have to pay GitLab, and GitLab would have to pay Google or Amazon, which is not, I guess, a model GitLab would like to go towards.
Why would they have to pay GitLab?
Instead of getting credentials for their...
Oh, I see. So now we become kind of the middleman.
Like
we have to manage all the infrastructure. And
Definitely.
I'm not sure we want to do that. So when we were talking about PaaS, one of the big pushbacks that I got from Sid is that he very clearly said, we don't want to be a compute provider. And if we want to provide you with like a free cluster or free compute, even if it's just a little bit, we would have to become that, because we either give you a path to graduate to like self-managed infrastructure, or we say you can scale it and we'll just bill you. And that's like a whole different business model, and it's not our expertise per se.
Yeah. Okay.
All right. So I was saying that the kind of things that we would do here are twofold. So we can flag the deployments that are over provisioned, and that happens like in every Kubernetes talk that you go to. They tell you, yeah, so we noticed we over provision our cluster, but like by like 150% or something like that. So we were only using like 5% of the capacity, and we only realized that 6 months. So like we wasted all this money, all this time, because we didn't know, because we were too busy kind of fine tuning the platform, and we were not looking at the costs. So we were very well positioned to let users know that they're wasting resources. And we were very well positioned to recommend what changes they can do to increase efficiency. So for example, you can use less nodes, but the nodes are a little bit larger. So like maybe more RAM or, things like that.
Yeah.
And then if it would be really cool if we could estimate the dollars and cents based on the cloud provider you use. Like, okay, we see you're on Google. We know that the Google costs today are these because we pull them in from an API. And we see that they are this. So if you change to this schema that we're telling you, where you use a larger node but use less of them, you would save $1,000 a month. Yeah, that would be, that's like,
would be super cool.
That would be the great thing to do here.
Can I ask something here about opportunities for features? In a new application, is there any way to predict based on similar application data or customer expectations of their customers, usage of their application? Could we predict what kind of resources they would need and recommend based on data analysis of other?
Absolutely. So we could have a model where we could even use machine learning or something like similar, where we have a model where we estimate cost utilized by your project automatically based on a trend. And we're saying, hey, your project has been trending like so, and by 2020 June, your cluster use is going to be at 90%. So we recommend that based on this trend, you resize the cluster to X, Y, and Z, or we'll give you the option to automatically do it for you. That would be the coolest thing ever. Yeah, and I'm sure that there are a lot of people out there in the market working on this problem already. The cloud providers, I think, being the main one.
Yeah, I guess they come first.
Yeah, but the nice thing about doing that in GitLab is that you have the portability. If you want to have a feature like that, it means you have to be married to AWS for the rest of your life. And people want freedom to think, hey, if something goes bad with AWS today, I can simply move all my stuff to GCP tomorrow, and GitLab allows me to do that, like, with a couple of operations. It's very seamless and painless.
Yeah.
Versus, I'm going to miss all this functionality.
We could provide them for all the providers, if we could, estimates, and then they could see that on-premise, even, they would pay so much. And if they were using a cloud provider, they would pay so much, et cetera, et cetera.
Yeah. So all the providers is tricky because there are so many. You would have to choose maybe the top 3 or the top 4 or those that we have a partnership with. So like DigitalOcean is nowhere near the top, but we have a partnership with them. So like we want to surface their functionality and their stuff in GitLab. But it wouldn't be realistic to say that we'll do it with all. Let's say we'll do it with the, top 3 or 4.
With the most used ones. The most common. Yeah. But it would be so cool. Okay. Is that something on our roadmap, or is it a dream?
Well, it's not on our roadmap yet, but it is. I think it's part of the vision. Yeah, it's part of the strategy for sure. It's not something that's scheduled on a milestone, but it's part of the vision for sure. Yeah.
Cool. So how do we phrase this job? Okay, we were at the first solution. So as an operator, we could tell them how much money.
As an operator, let me see. As an operator, I want to find which resources in my infrastructure are over provisioned / under provisioned. So both, right? So that I can save on costs or manage these costs, however we want to put it, and also appropriately size the resources for the needs of the applications running on them. Or for the needs of the applications running on them.
And appropriately resize.
Size / resize these resources based on the needs of the applications running on them. And so to give you an idea of like the market share of the biggest clouds out there, So AWS should be really the thing that we focus on the most. So AWS has about 47% of the market.
Okay, so it's almost half
Then
the market.
almost half the market. And then the rest, the half is like split very unevenly. So Microsoft has about 15%. Alibaba has around 7%. Google 4%. And IBM has around 1%. And the IBM cloud, like in my opinion, for Kubernetes workloads is like terrible.
I missed some of the percentages. So Azure was 15%?
Yeah, around 15%. Like all of these might have changed at the end of 2019, but these were somewhat recent. So Azure is around 15%. Alibaba is around 7%. Google Cloud's around 4%.
Wow.
And IBM's around 1%.
I'm surprised with Google Cloud. Did it come later than AWS?
Oh yeah,
Okay.
Way later. So AWS like had a head start like years and years. That's why they are the de facto leader in cloud computing.
But then Kubernetes was created by Google, and this is the main thing for running your applications on the cloud.
They are making big bets on cloud native topologies. And like if you have a cloud native app, they want people to think about GCP as their cloud of choice.
Right.
But yeah, Kubernetes is, even though it was born out of another project that was called Borg inside of Google, it is now CNCF project. So it's, like it has many contributors. Yeah.
Yeah. Okay. So AWS is the one we should be focusing on, but then we want to be there first for serverless, which means
market share wise.
Yeah.
But what I would love to do is within GitLab customers, what's the cloud like split? I would love to see that. And I'm sure that, that's going to be very hard to find because we don't have a way to pull customers like all of our millions of users saying, hey, what's your cloud of choice? So, but so we can adjust to the market and say AWS is clearly the leader, and we want to like people that use AWS to think about GitLab for software development. And it's a very contentious problem because AWS competes with us in developer tools. So they have their own version control tool, they have their own CI tool, they have basically a full developer stack.
They do? Kind of similar to Atlassian? Or like
Yeah, exactly. Well, yeah, kind of. Atlassian, I think, is very well known for like portfolio management and Jira, which is issues and stuff like that. So I think AWS is less that, but they have a lot of like pure development tool services. Yeah.
Yeah.
So let me link you here. And it's like growing, and they're hiring like crazy, and they want to have a seamless experience with their tools if you're on AWS. So for example, there are tools like Code Deploy and Code Pipeline, and they integrate very, very well to your repo if your repo is the AWS code repo or GitHub. I do have to say that they integrate across the board with GitHub. But so if you're with GitLab, you're kind of SOL, right? Because you have to do a lot of more manual work.
Yeah.
So if you're a developer and your infrastructure is on AWS, what they're betting on is that you'll use the AWS developer tools.
Yeah.
So it's it's kind of, if you think about it, we are competing with them in that space.
Yeah, gotcha. And also for Lambda, it will be the same. I guess.
Well, so the big difference there is that they are an infrastructure provider. We are not. So we are only competing in the developer tools. So the developer tools allow you to easily deploy to Lambda, and we want GitLab to be the easiest way to deploy to Lambda, even easier than the AWS code tools. Yeah.
Okay. Scary competing with Amazon, but
Oh yeah. But fun. Yeah. How fun.
I guess if we had a head start, it's going to be fun. Otherwise,
Yeah. And the reality is that people generally use GitHub and is very well integrated into AWS. So if you're on GitHub, you generally don't have to switch or don't have an incentive to. But if you're on GitLab, it's not natively integrated with most of the AWS services, so it's going to be a little bit more painful to use them. So it's on us to make it easier and seamless, basically. Yeah. All right, so that's cluster cost optimization. I think that we covered it very well, I would say. Then I don't know if we talked about serverless or if you even want to talk about system stuff with me, or you rather have that conversation with Victor, but there's a bunch of operator related jobs to be done in system, especially because it has like infrastructure as code, and infrastructure is a very operator related category, as is runbooks. So runbooks are squarely aimed at operators. Yeah, and I think that we might have talked about runbooks last time, no?
Yeah, going through the vision and what they are.
Okay.
So Victor has provided a number of use cases in a separate issue than the one you commented recently. So maybe I'll start by documenting these and then cross-checking. And then in our next meeting, we can discuss if you think there's a use case missing on the system side, system feature side. What do you think about that?
That's great. That sounds like a plan.
Okay, cool. I think for today, it's good because I need to document and digest all that.
Okay.
And yeah, next time we can, I don't know, we'll see, depending on how jobs to be done go, we can prioritize and say, I'm going to start by examining those.
Okay, that sounds good.
Okay, cool. Well, thanks for your time.
Absolutely. Thank you. De nada, con gusto. I'll see you. Well, I'll probably see you before next week. I'll see you around.
Tomorrow, I think, at a weekly meeting.
There you go.
Mañana.
Mañana. All right, Maria. Thank you. Have a good rest of your day.
You too.
Bye.
Bye-bye.